Hello and welcome to this learning video. As you all know that we have started the topic application of linear differential equations to electrical circuit, and we have already taken one problem where we have discussed the notations, the basic terminologies required for application of electrical circuits, application of differential equation to electrical circuit. So I suggest you to go through that video lecture first, because the terminologies and the basics that we are using in this topic are already discussed in the previous learning video. So I want you all to go there first, go through that video lecture, and then you can continue with this lecture. In the last learning video, you have seen that we are given an equation of circuit, and then we have to find out the current. Okay, but this is not the case all the time. Sometimes circuit equation is given to you, and sometimes circuit equation may not be given to you. So the problem in which the equation of circuit is given to you, we have already taken. Now here in this learning video, we are going to take the problem where the equation of circuit is not given to us, and we have to actually derive or write the circuit equation first, and then we can solve it further to get the desired result. Okay, so let us see here. So this says a 20 ohm resistor is connected in series with a capacitor of 0.01 farad, and EMF E volt is given by this. If Q is equal to 0 at T equal to 0, this is the condition which we will be using to get the value of the arbitrary constant. Then show that the maximum charge on the capacitor is 0.25 coulomb. Okay, so first of all, as you can see here, the circuit equation is not given to you. So the very first thing is that you have to write down the circuit equation. If you are smart enough to write down directly the circuit equation, well and good, and you can go with that. If not, then let me draw the circuit first, and then with the help of circuit I am going to write down the equation of circuit, and then we can continue. Okay, so what is given? A 20 ohm resistor is connected in series with capacitor. So we are given a resistor connected with capacitor. Okay, so this resistor of 20 ohm is connected with the capacitor in series, of course. So this is given to us, and resistor is connected in series with capacitor 0.0. If you want, you can just write it here like R is equal to, this is 20 ohm. You can write it here as farad 0.01. Okay, if you want, you can write. Now if you can look at this, what I have done, just read the question, try to draw the circuit, and then with the help of this write down the circuit equation. So what would be the circuit equation for this? Now to write down the circuit equation for this, what is given? A resistor is connected in series with capacitor. So what I need the voltage drop across this resistance. And what is the voltage drop across the resistance? That is Ri, that we have already seen in the last learning video. Likewise, what is the voltage drop across the capacitor? So the voltage drop across the capacitor is Q by C. Okay, now with the help of this, I am going to write down the circuit equation for this. Okay, so just writing this one as the circuit equation is, what is it? Resistor is connected in capacitor, so voltage drop across this plus, because it is in series, plus the voltage drop across this capacitor. So this is R I, okay, plus voltage drop across this is Q by C is equal to electromotive force E. Okay, now what is this I? This I stands for current, Q stands for charge, C capacitor, R resistor, and this is electromotive force. So to get the differential equation, I must have the ddt, rate of change. So I can just replace this current as rate of change of charge. Okay, so I am going to write this one as R into dq by dt plus 1 by C Q is equal to E. Is it okay? Now you can substitute the values of this also, but before that you can just make the coefficient of this dq by dt as 1 by dividing by R. Okay, so it is dq by dt plus 1 upon RC into Q is equal to E by R. Now you have all these values, so you can just find out these values and substitute over here. So what is given? Say this is to be my equation A or equation 1. Given that, what is given? Given that R is equal to 20 ohm, C is equal to 0.01 farad, and E is given to us as 40 e to the power minus 3t plus 20 e to the power minus 60. Okay, this is given. So what is this R into C? 20 into 0.01 is 0.2. So 1 upon 0.2 is 5. Okay. So therefore 1 upon RC is equal to 1 upon 20 into 0.01, that's 0.2. 1 upon 0.2 is 5, and E is already given to us as this. So this put it in this equation. Equation 1 becomes or implies dq by dt plus 1 upon RC. What is RC? 1 upon RC we have found out, that is 5Q is equal to, what is E? E is this, and what is R? R is 20. Okay, so you can directly write it as 20 e to the power minus 3t plus 20 get cancelled, e power minus 60. Simple. Okay, now say this is to be my equation number 2, and you can just look at this equation 2. What is this equation 2? This equation 2 is nothing but a linear differential equation in Q and T, where Q is dependent and T is independent variable. Okay, we can write here, this is linear differential equation in variable Q and T with Q as dependent, of course variable Q as dependent. Okay, now solving this type of equation is not a big deal to you. Just find out the integrating factor and write down this solution. So here you can write P and Q. This is differential equation of the form. This is linear differential equation in variable Q and T with Q as dependent variable. Okay, and if this is like dq by dt, This is linear differential equation. Okay, so this dependent variable of the form, dependent variable with q as dependent variable of the form dq by dt plus p into t is equal to q. Okay, sorry, p into q is equal to q. Okay, now what is my p? P is 5, where p is equal to 5. What is q? Q is this 20. Is that 20? That should be 2. Yes, that should be 2. This is 2 e to the power minus 3t plus e to the power minus 60. So let us find out the integrating factor. Therefore, integrating factor is equal to e power integration of 5 dt. So this is e to the power 5t. After getting the integrating factor, you just have to find out the solution. Solution of what? Equation number 2. Hence, the general solution is, what is it? Can you write down general solution for this? Yeah, this is q into integrating factor is equal to integration of this q into integrating factor dt plus some constant of integration c. So you can just substitute all these values over here. So this is q into integrating factor e to the power 5t. Integration of q is 2e to the power minus 3t plus e to the power minus 60. This is my q into what is integrating factor e to the power 5t. Okay, dt plus c. So you can just solve all these things. So when you solve this, you'll be getting q into e to the power 5t is equal to, multiply this to this, you'll be getting 2 times integration of e to the power minus 3t e to the power 5t. So this is e to the power 2t plus e to the power minus 6 plus 5 e to the power minus t dt plus c. And this is the very elementary integration that each students of mathematics can easily write. Okay, so this is q into e to the power 5t is equal to 2. This is not here, this 2 is here. Okay, 2 e to the power 2t by 2, this get cancelled, plus e to the power minus t by minus 1 plus c. Okay, now you can divide by this e to the power 5t so that we can write down this equation in terms of q, and we can able to apply the conditions given to us. Okay, so what is it? We have this, so you just have to divide by e to the power 5t. So you remain with, what is it? Q is equal to e to the power 2t divided by e to the power minus e to the power 5t. So this is e to the power minus 3t minus e to the power minus, and this minus 5, this is minus 60 plus c e to the power minus 5t. So we have this equation. Say this is to be my equation number, which one it is? Okay, I don't remember exactly. So say this is to be equation number A. Okay, now we have the solution of the linear differential equation, but it contains constant, and this value of this constant can be found out by this condition, okay, given in the example. Okay, so given that q is equal to 0 at t is equal to 0, therefore equation A implies, what is it? Q equal to 0. This is e to the power 0 minus e to the power 0 plus c e to the power 0. So this implies c is equal to 0. 1 minus 1 0. This is e to the power 0 is 1, c equal to 0. Okay, after getting c is equal to 0, rewrite the equation A. Then equation A becomes, after putting c is equal to 0, equation A becomes q is equal to e power minus 3t minus e power minus 6t. That's it. That's my q. Say this is to be equation B. After getting this q, I need to find out the maximum charge, right? Because this problem is of show that, and which says show that the maximum charge on the capacitor is this 0.25 coulomb, and to find out the maximum charge I need to apply the second order derivative test for maxima. Okay, do you remember what is second order derivative test for maxima or minima? So let me remind you of that thing. So if you have a function, say f of x, and if you want to check whether this function is maxima or minima, so the very first condition is try to get the stationary point of this by taking its first derivative equal to 0. We will be getting the value of x for which f dash of x is equal to 0. Then make use of this value in the double derivative. Then suppose x is equal to a. Suppose, then what we do, we put a in this f double dash, and if it comes out to be negative, then this is the function f has a maxima at x is equal to a, and to get the maximum value we put x is equal to a in the given function. Okay, here in place of f function we have q. Okay, now to find maximum charge, to find maximum charge q max, I will be denoting maximum charge as q max. Okay, and for that, as I said, I am going to apply the second order derivative test. So let me continue with that. For maxima or minima, the first condition is as it is. Okay, for maxima or minima, dq by dt is equal to 0. Okay, so what is dq by dt? We have q, so find out its derivative. So this implies, what is q is this, so what is dq by dt? Differentiate this b with respect to t, so we get dq by dt is equal to e to the power minus 3t into minus 3, it's a derivative not integration, minus e to the power minus 6t into minus 6, so this become plus. So dq by dt is 3 to the power minus 3t times this. Okay, now what you can do is, if this is equal to 0, now I have to get the value of t. Either you get the value of t or you get the value of e to the power minus 3t. Okay, because this involves e to the power 3t only. So this can be done by taking minus 3 outside, e to the power minus 3t outside, remain with 1 plus 2 e to the power minus 3t, because this can be written as e to the power 3t into e to the power 3t, e to the power minus 3t we have taken common, so 1 plus 2 e to the power minus 3t equal to 0. Minus 3 not equal to 0, this is not equal to 0 being exponentiation function. Okay, so this must be 0. This implies 1 plus 2 e to the power minus 3t equal to 0. This gives you e to the power minus 3t is equal to minus 1 by 2. Okay, so I am getting e to the power minus 3t is equal to 1 by 2. Okay, now what I am going to do is I am going to find out the second derivative of this. So we already have first derivative, means you just need to take derivative, one more derivative of this, put e to the power minus 3t 1 minus 1 by 2. If the value comes out to be less than 0, then this function has a maxima at e to the power minus 3t equal to minus 1 by 2. And to get the maximum value, we will substitute this value over here in q to get q max. Okay, so find out dq by dt here. d2q by dt square is equal to, what is it, minus 3. So this is 9 e to the power minus 3t, then this is minus 36 e to the power minus 60. Right, now discuss this at point this e to the power minus 3t equal to half. Just give me a moment. At e to the power minus 3t is equal to minus 1 by 2, d2q by dt square is equal to 9 into e to the power minus 3 by minus 3t is this, minus 36 e to the power minus 60 can be written as e to the power minus 3t into e to the power minus 3t. So I can just put here 1 by 2 into 1 by 2. Is that correct? Yeah. Minus 1 by 2, minus 1 by 2. Okay. Just a moment. Yeah, this is minus, sorry, just a correction. So you can take it like this, minus 1, because otherwise this should be minus. We have taken here minus 3t common, so this is 1 and this should be minus 2. So this is minus and this should be plus 1 by 2, plus 1 by 2. Sorry, this is plus 1 by 2 and 1 by 2. So as you can see, this is 9 by 2 and this is 36 by 4, 9. So 9 minus, sorry, 4.5 minus 9 is minus 4.5. So this value comes out to be less than 0. Means q is maximum. Means q, therefore q is maximum at e to the power minus 3t is equal to 1 by 2, and the maximum value and its maximum value is q max is equal to e to the power minus 3t, which is 1 by 2. E to the power minus 60 can be written as e to the power minus 3t into e to the power minus 3t. Okay, and this value is 1 by 2 and this value is also 1 by 2. Clear? Okay, so this is 1 by 2 minus 1 by 4, that's 1 by 4. So this q max is equal to 1 by 4, or you can write this one as q max is equal to 0.25 with with units you can write, and this is what we wanted to prove. So I hope this problem that we have just taken is gettable to you. So thank you for watching this learning video and have a good day. Thank you.